So now that we've got folks coming in, before we get started and get to introduce Trey and go through some slides about his background, we've got a quick video that we're going to play from Aerojet Rocketdyne. So give us one moment. In case you couldn't tell, tonight's webinar is going to be about rockets. But before we get to all of the rockets, first we need to introduce the man of the hour, Tre Butler. So, Trey,
How's it going? How's it going? Can you hear me?
just loud and clear.
Cool, cool. All right, I guess I'll take the ball. Good evening, everybody. Nice to meet you. My name is Tre Butler. I work for Aerojet Rocketdyne. I'm a design engineer for solid rocket motors. All right, so a little bit about me. I am from Greenville, South Carolina. It's kind of on the tip, more upstate South Carolina. I graduated from high school back in 2016, and I guess just like a little cool little throw in, I took my first aerospace course when I was in high school. So that was like my first technical exposure to it, and I'll touch a little bit more on that later. Some hobbies of mine, definitely building anything. I like to build like furniture, build like just random things around the house, fix things. That's where I find my joy. Any sports, I like to stay active, go to the gym, basketball, football, and traveling. I like to travel to different states. I want to travel to different countries, especially once Corona gets really moved out the way. So any type of traveling is a love of mine. And my favorite quote, I didn't come this far to only come this far. I tell everybody that, you came this far to keep going. So that's my favorite quote. Moving on to where I went to school. So I graduated from Clemson University in South Carolina back in 2020. I received my bachelor's of science in mechanical engineering. And I did a concentration of aerospace engineering. My favorite courses were aerospace propulsion, where we got to go into basically what I do for my job. And then machine design, which is more the how do you model things and do the other side of my job with like the CAD work and stuff like that. Favorite pastime was definitely go see the Tigers play. We won the championship twice when I was in college, so it was amazing atmosphere, amazing, school. So definitely going to see the Tigers play, and also just go around and travel to the mountains and go hiking and just hang out with friends. So my involvement, I did two internships. The first one was with Arconic, which is up in Cleveland, Ohio. I worked as an aerospace engineer structures intern, where basically I worked with large engineering parts, large aerospace parts, such as like fuselage, structural parts, and it was like an aluminum company. So we did a lot of big casts and dies and prints and stuff like that. The second one was with BMW in South Carolina. I wanted to see more of the automotive side and just, kind of get a feel for things. And I worked as a production control and process improvement intern. Great experience, but I knew I wanted to go back to aerospace. So once I graduated, I jumped back into it. My involvement while in Clemson was critical in, I guess, like my growth as a person, as a student, and, more and more. So I look to stay involved. My probably most treasured one was NSBE, National Society of Black Engineers, where I was given the opportunity to go to national conferences all across the US. So we had conferences in Phoenix, went to Pittsburgh, Detroit, and we were given the opportunity to meet upward 15,000 engineers from all across the country and the world. All came to these national events. I ended up getting both of my opportunities for internships while I was at these conferences. Going to my fraternity at Kappa Alpha Psi Fraternity Incorporated, I joined back in 2018, and that was more of the social side, getting to form that relationship with people on the campus with me, and that was critical in like my social growth while in school. Peer mentor. I was the peer mentor is basically like Clemson's program for I mentored incoming freshman engineers. So I was given around 12 each year. I did it for 3 years, and I just kept them every year. And we would have dinners, we would go places, have fun, and just kind of made sure that, being a new student on the university, that they kind of got acclimated pretty well. And then the last two are my creative inquiries, which are just kind of like in-depth courses on things that I might be interested in. So I'm not going to get into it too much. So Aerojet Rocketdyne. So y'all saw the video with the rockets and the big spaceships. And I mean, we do all types of things. We're a world-class developer and manufacturer, as the site says, of propulsion. That's what we do. We supply to the military, we supply to NASA, we supply to all these other companies and basically do whatever challenge they give us. That's our golden, form is like we're given a task and we have the talent, we have the ability to make it happen. So our markets that you see are space. I'm sure you've seen like the launch vehicles, satellites, the SLS, all of that stuff. Like we power space. That's our key, our foundation for the last over 50, 60 years. Defense. So that's the sector that I work, working on missile defense and propulsion for that. And we have new contracts with GBSD and NGI, and I'm sure more to come down the road. And then we also look to be innovative in all of our production. So new things down the road, hypersonics, additive manufacturing, and green propulsion. And I mean, there's so many other things beyond the scope of what, you see here, but always looking to grow. So my role, I am a design engineer for solid rocket motors. Basically, so you have liquid rocket motors, which is more towards the space, and you have the solid rocket motors, which is more towards defense and missiles. So I work in the defense side of it, and I love it. I get to work many programs, CAD programs, and basically see a rocket go from ground zero all the way up to launch and testing and everything. So being fairly new to the company, I've gotten to jump into a role where I'm learning a lot. Every day comes with new challenges. Every day comes with new opportunities to learn and grow within my position. So I'm stationed in Huntsville, Alabama, at the defense headquarters, and I love it. A lot of opportunities for growth, and a lot of cool stuff being done here. And yeah, I think the best thing about being a design engineer, and I can talk about it when we get to the Q&A some more, but it's just being able to use your own intuition, use your own skill set, your own mind to kind of make something that works, better than the way that it was done before. So that's the cool part of my job. It's not like I'm stuck to a script or anything. It's, what do I think? How can I incorporate it? And how can I prove that my way works? So what's next? For me, going back to school. So I just got into my graduate program. I'll be starting in the fall to pursue my master's in aerospace engineering. And really just kind of working alongside the most intelligent people I've ever met. I mean, everybody here is very sharp and professionals at what they do, and they just know so much. So every day I'm asking questions. Every day I'm trying to learn more. So that last note is just never giving up on my desire to learn, like accepting that I'm here and I want to get here and not accepting where I'm at. So yeah, that's me. Quick little kind of rundown of it. And I want to open up to some questions. I can't hear you.
Yeah, man, I've done so many webinars and hadn't had that happen. Before we even get into the questions that we had running ahead of time, I wanted to ask if you wanted to share where exactly you're going for your master's.
Absolutely. So I'm going to the University of Alabama in Huntsville. Great program here. There's a lot of aerospace companies in Huntsville, Alabama. So a lot of professionals who are pursuing their extra degree go to UAH. So I'm excited. Always willing to learn more. So UAH, University of Alabama in Huntsville.
All right. And so, thank you, and shout out to some of our alumni that I know are actually at University of Alabama as well. Um, so you've told us a lot about your background, everything that you've done, but what I'd like to know is what was the moment that brought you into the aerospace industry? Was it one particular moment or experience, or was it a bunch of things, or how did you? What was the spark for you?
No, definitely. I think there was a lot of different things being fed into, but if I had to pin it on a moment, was being able to tour the NASA location in Texas, and that was the moment where my eyes were just open. I fell in love with it. It was like I had lived in such a small world, and then there was just so much more out there, and then that just kind of triggered something for me to look up space, and I fell in love with space. And I was just, I told my mom, I was like, I want to go to space, and I want to like figure out what it takes to do all that. And it trickled down through my years, and I just knew that, you know my heart was always in the air. So
That's a great way to put it. My heart was always in the air. Man, that's um now, obviously that was when did you get the chance to tour the NASA facility over in Houston?
it was right before I went to high school. So I think it was my eighth
Oh,
grade summer going into high school. So I was a little late, but definitely changed my life.
so you figured it out pretty quick, but knowing what you know now and having gotten to Aerojet Rocketdyne, getting ready to start your masters, what's a piece of advice you would give to yourself back when you're just starting high school and you just had your eyes open, knowing where you're headed?
I would definitely tell myself to never accept average, to never accept just being, normal. Always try to push the boundaries. A lot of people get comfortable, and I think I would tell myself to never get comfortable, to always be willing to step outside and be okay with not knowing some things, but always willing to learn things. So I think I got to the point in high school where I was like, okay, I'm good at this, so I'm going to stick to this. If I had to go back, I would tell myself to push those boundaries, like really apply some pressure, and just, I mean, be okay with failing, because that's how you learn.
And we actually just got a question coming in from an attendee asking, how do you recommend students who are unsure to figure out whether this is something they'd like or be good at? It's there you go. Just give it a shot. Um, so you're talking some more about high school and branching out and giving things a shot. Um, you know, how important would you say, being where you are now, is it to focus on one subject in high school, for academics, or should you really be exploring more of those options? And that's coming from Sebastian from the Trinity School.
Okay, great question, Sebastian. My honest answer is explore out. Explore out. Don't get so hyper focused on one thing, because life throws things at you, and it can change. Like there was a time where I thought I wanted to go work on airplanes, and then I went to rockets, and then I was like, well, maybe I want to do airplanes again. So it's like you don't want to get too focused on one area because you could limit yourself. So kind of have a direction, but be willing to learn more outside of that, and then you become more valuable, you become more flexible, so that when other things do come, when other tasks do come, you're not so laser focused on one area. You're more diversified, and it makes you a better candidate down the road. So definitely diversify, but also have like kind of goal in mind. It's like, okay, this is what I want to do, however I'm going to be good at all of this.
All right. And just a reminder to everybody in the audience, please use the Q&A function in Zoom, so that way we can see your questions and get to them. Now we've got one question coming up here from Jay from Great Valley High School, who's asking, I want to learn more about aerospace and build more advanced rockets. Can you recommend any programs I can get involved in?
Yeah, absolutely. I can give a little what I know, and you can take the ball from whatever you want to add to it. But definitely, I mean, y'all are already a part of this program, but AIA, I mean, just continue to grow within and see what they have to offer. And NASA has steps up, and they have programs that they do also. And then also, when you get to college, colleges run their own events. They have their own organizations and clubs. So please help me out on the details, everything.
Absolutely. So if you're participating in the American Rocketry Challenge, the best next step is going to be with the NASA Student Launch Program. In fact, in a normal year, the top 25 teams from the national finals get invited to a summer workshop where they get to work on their proposals. And in NASA Student Launch, you're really tackling high power rockets that are going several thousand feet up, that have got payloads like
Oh no.
rovers or drones. Um, and those are all being used to do some really amazing missions there. So NASA Student Launch Program is going to be your best bet for there. And then, just like Trey said, your university is going to have something going on. And speaking of something going on, it looks like we're having some technical difficulties. So use this opportunity, everybody, to get your questions in. So we will get everything taken care of there. And we are
Okay.
back from a brief technical difficulty. There is nothing like recovering a launch vehicle mid-flight. So
Oh gosh. Okay, we're good.
Jay from Great Valley, best answer there is NASA student launch. Um, we've got a really fitting question right now from Carly Tomlin asking, what are the character traits that work best in the aerospace defense field?
Being attentive to detail, being prepared, um, always willing to learn. I mean, there's a whole list, but just always willing to adjust in situations, just like just now when everything went crazy. I mean, that's kind of what happens. You had to make adjustments. You had to make quick changes, quick fixes, and not panicking. Being able to take what you're given, adjust, analyze it, and then adjust. I think that's just good advice for engineering in general, but definitely in this industry, it's fast paced. It's always changing. It's always adapting to what's desired. So just being able to be a quick learner.
Absolutely. And speaking of learning, we've got a question here from Kimia Kobadi. How did you know what master's program you wanted to pursue? And, what are the challenges you're looking at where you're going to be pursuing your master's while presumably still working full time?
No, definitely. That's a great question. I knew going to college that aerospace was where I wanted to be. So back to the diversifying yourself, I knew mechanical would give me the opportunity to experience many types of engineering fields. So mechanical would get me into aerospace. And I said, okay, I'm gonna go mechanical for my undergrad, and then I want to specialize and get my master's in aerospace so that it makes me a more valuable player to these companies that are looking for more technical and more experience and stuff like that. So balancing it with my job, Aerojet Rocketdyne has a great program where a lot of their employees, I mean, a lot of them do go back to school while working. So they understand, I mean, great resources, great help. I'm sure it's going to be challenging. I'm sure it's going to be difficult, but I mean, that's just every day. You know, every day you get hit with a new challenge and you do what you have to do to figure it out. So I'm excited. I'm looking forward to it, but you know, it comes with its challenges.
Yeah. And a quick follow up from Kimia. Are you doing a thesis route or classes?
I'm just doing the classes. The thesis was not that appealing to me, so I'm going to take the 2 extra classes.
There's no shame in taking the safety there. Um, Shifting gears real quick over to talking about solid rocket propellant, because you know that's what all these students model rockets use. So we've got lots of questions there. From David Newell. Are you now, are you being Aerojet Rocketdyne in the aerospace industry, 3D printing and using additive manufacturing for solid propellant and not just the structural parts? And if that is something that's happening, what are some of the advantages and challenges there?
Um, Company wide, it steps. Let's say they're looking into it. I'll say it's been looked into. We're still on more of the structural side, um, but there are a lot of opportunities in doing 3D printing. But you know, when you're working with propelling, you're working with very sensitive materials. So it's a little more difficult doing it with that route rather than just doing a structural part. So I think
Since
getting the structural part has been really cool. But yeah,
Yeah, sensitive might be an understatement for solid rocket propellant. Now,
definitely.
talking about some of the more advanced things on the horizon, we've got one person in the audience who's saying, love the background. What is the ship? What's the airframe that's over there in the back left? Hmm.
Yeah, so that's a part of our hypersonics. So I spoke about it earlier. It's the next generation of just propulsion, just having hypersonics. So our facility in Florida is actually kind of really focusing in on the hypersonic part of our company. So they've done extensive research and they've gotten Army approval and government approval on this type of research. So it's definitely the future, and I mean, I'm proud to say that Aerojet Rocketdyne is leading that cause, leading that race in that area of propulsion. So yeah, really cool, futuristic, but it's here. It's here. We're working on it currently, and I mean, I'm sure you'll see more about it in the future.
All right. And talking about, solid rocket propellant and what's needed to approach challenges like that with hypersonic vehicles. We've got one question here from Madeline from Madison West High School. You know, how is total impulse for a rocket motor determined, and also specific impulse? And does that need to be tested, or can it be just accurately determined from the composition?
What a great question, Madeline. Um, So total impulse, to kind of break down your question, total impulse is, in simple terms, it's just your thrust created during the duration of that time. So your thrust times your duration. So not as desirable as that we look at the specific impulse. That's more going to give us the direction on how we build our motor. So that specific impulse is driven by time. We want to know, how long do you want this to burn? So yeah, when we get the propellant, we can do calculations. We have ballisticians that, will say, okay, we can burn this propellant at this volume for this amount of time. And that's great. So we can do it by the composition. However, you always want to test. So to answer your question, yeah, it's calculated in simple terms, just your thrust by your duration of time. However, we look at basically your requirements, which are directly related to your impulse. So how long do you want it to burn? And we test it to back up our ballisticians and our design efforts, and then we just adjust. So great question. That's a great question.
All right. And we'll go ahead and take a little bit more of a complicated one that came in ahead of time too, related to some solid rocket motor fuel. So in lots of the composite motors that are used in model rocketry, they use ammonium perchlorate composite propellants, and those are often burning aluminum as fuel. And so we've got a
Mm-hmm,
question from Harold from Seabrook Intermediate who's asking, why, if they're burning aluminum as fuel, why don't those
mm-hmm,
composite propellants ruin or burn through the aluminum reloadable motor cases that model
mm-hmm,
rocketeers use?
mm-hmm. Another great question. It all comes down to the design of the motor. So you have your ammonium, your what is it? Ammonium perchlorate, and that is going to be encased within the bottom of that solid rocket motor. So when it comes down to your layers, which is what we want to look at as a design, you have that layer of insulation that's surrounding it. And then on the other side, that aluminum that it's reacting to is in a powder form. So it's not like it's in the solid aluminum like the casing is. So it's in a less reactive, I mean, it's in a more reactive powder form that's serving the purpose to basically oxidize and use that fuel to cause that explosion that happens. And then you have that insulation that goes into the bottom or towards more toward the nozzle area of the rocket. So that aluminum casing that you're concerned about, it's not catching much of that contact that fuel that propellant that is the aluminum is catching. So it's more so just kind of holding it all together and just giving you that form and shape. And it's catching some heat, it's catching some reactive forces, but nothing to ruin it. So when you pick your designs, you pick your shapes and everything, you do it based off of your impulse, your specific impulse, and how you want to function. That's what makes it, I guess, a usable product. I hope that answered your question.
I do too, because we got a bunch of young little rocket scientists here, and they are clearly throwing the hard ones at us. So feel free to
Oh
keep those
boy.
questions coming in the Q&A. Um, but sort of moving away from the hard science, what's been one of the coolest experiences you've had because of your work at Aerojet Rocketdyne?
Yeah, that's a great question. So I guess I need to give a little background to my history with Aerojet Rocketdyne. I've only been here for a little over 3 months. 3 months. So so I'm still fairly new. But I've gotten a lot of chances to learn and explore around. So I think the coolest thing that I've had happen was being able to watch a rocket test. So basically it was called a burst test. So we wanted to take it all the way up until it explodes. And that was like the coolest thing, just for our purposes. It was it was done safely, but it let us know, okay, this is how well we put together this rocket. It wasn't my program, but it was another program. But being able to witness that in my early stage of my career, I mean, I got excited. I felt like a kid all over again when I first got introduced to aerospace. I was just ready to jump right in. So I think that was the coolest thing, and I'm sure there's many, many more cool things to come.
Awesome, and many, many more launches to come too. Um,
Definitely.
we've got a question here from Rebecca Bonebreak asking, speaking of high stress, would you say pursuing a rocketry-based career is high stress academically?
Um, I would say, I would say it can be. I mean, engineering in general is. challenging. I mean, what we do is difficult stuff. We solve problems. We solve things that there might not be a straightforward answer to. So, yeah, it's going to be challenging, but you have to think. I mean, in this career, you make a mistake, it could be at the cost of a life. It could be at the cost of billions of dollars. So it's high risk, but I mean, when you go through these courses, when you are pursuing your academic, career and your academic path, challenge yourself because the industry is going to do it anyway. So you might as well challenge yourself while you're in these classes, while you're in school. So you'll be more prepared for the industry doing it.
And I was going to say, this really comes back to what you were talking about towards the beginning of the webinar with, what advice would you give to yourself to always pursue new things and challenge yourself? You know, no matter what you choose to study, if it's focused on rocketry and propellant, if it's focused on aerostructures, if you're focused on orbital dynamics, orbital mechanics, or if you're looking on the policy side of things for space, any of these routes into the aerospace industry, if you're doing it right, it'll be challenging for you academically because you're always seeking out those challenges.
Exactly. I agree.
So, all right. Looking over, we've got another question from Carly Tomlin asking, what does a typical day look like in your job? Is it more consistent where you know exactly what you're doing each day of the week, or is there, things popping up and you've got to go from A to B?
I would definitely say every day comes with its own challenge, and I love it. I love it. I'm the type of person where I I can't sleep when I can't figure things out. So coming into work, we might have a design change. The customer might say, "Hey, we want it this way," or whatever it might be. Every day comes with its own challenges. It comes with its own changes. And that's the beauty of engineering. You get to jump in, solve problems, figure out different ways. And I mean, the greatest feeling, and I'm sure all of y'all can attest, when you make something and it works and it's done, best feeling in the world. So every day just kind of, crunching through it and then being able to say, I did that and stamp it, wonderful. It's worth whatever struggle the day comes with.
Absolutely. And I think we've got a lot of students that are getting ready this weekend with the national finals to feel that kind of
All
way
right.
about all the work they put in to get there. Um, and then talking about the work that you do, how much of your day would you say is working individually versus collaboratively? Or does that really just depend a lot on the project or the aspect of the project you're working on?
Yeah, that's a great question. I think it does depend. However, if I had to give a number, I think collaboratively maybe 60% of the day, and then by myself maybe 40%. If it's a more intensive time where we're trying to get drawings done, we're trying to get designs pushed, that can bump up to 90% collaboratively to 10% by myself. I mean, it's, sometimes we just book a conference room, or get on a WebEx or get on whatever, and we have problems to solve. So, um, you know, I would I would say it's pretty fair share more heavy on the collaborative work.
Mhm. And so, talking about collaborative work as well, you know, what are the sort of skills, not necessarily talking about mathematics and science skills, but for all of our students that are really interested in going into the industry, what would you say about the kind of soft skills and the teamwork skills to focus on there? What should our students be really looking at on how to practice those and learn those better?
Yeah, no, that is soft skills are very, very underrated, but they're so important in the industry. Being able to work with all types of people is key. Being able to learn, being able to listen, to adjust. That's how you grow. Not being so stuck on this is how I do it. This is the only way. Trying to hear other perspectives, trying to get more knowledge, is key, and being able to communicate your perspective is also important. If you have a good idea, if you have a good perspective, you know, don't be afraid to speak up. Like, if you have a solution, present it, share it. Don't be afraid to, everybody tries to not look dumb and ask dumb questions. I don't believe in that. Do what you have to do to get to where you need to go. So the soft skills, practice those are key. Just being able to step outside your comfort zone and really not be afraid to fail, but always be willing to learn.
And do you have any advice for our students where maybe they've been they're so focused on the aspect of the rocket that they're working on that they might not feel as comfortable branching out and saying like, what advice would you give to somebody who's trying to step out of their comfort zone to maybe think back on, remember, or help push them to expand their horizons?
Yeah, no, that is always a challenge, is being able to kind of put yourself out there, because you get vulnerable and you're like, okay, they're going to either laugh at me or they're going to be like, oh, that might be a good idea. Honestly, it's just going to come down to, just trusting yourself. Trust yourself, trust the math. I always say math doesn't lie. If it makes sense on paper, speak up. Even if you did something wrong, you won't know until you say something. You won't know if you can be successful until you really try to push yourself down that path. So if you have a great idea, if you have a new idea, if you have, ideas that you're not sure of, you'll never know how they're going to turn out until you bring them to the light. So it's a confidence thing. It's a confidence thing. And just it I don't know, just don't be afraid to just jump, you know.
Good deal. And we've got one question coming in from the audience asking, how do you learn new things? So with all the different things that you're building, repairing, working on, obviously there's lots of transferable skills around there, but what are the sort of places, books, media, resources that you go to when you're looking to pick up a new skill or say, oh man, how do I change this part on my car?
Me personally, YouTube is a great resource. YouTube, Google, books if you have them. Like, we have resources around the office, so I probably have access to more than what you guys would. But the internet is such a beautiful thing because it closes that gap of access to information. So just, if you have an idea in mind, if you have something that you want to figure out, like, I would work on cars, I would go to YouTube and say, hey, I have this problem with my car, and they would have a video out there for it. So I would say just explore around, and then like you mentioned, talk to people in the industry, people that are on the path that you're on. They are a great resource. They are great. They have a lot of knowledge, a lot of wisdom. They can get you on the right path for where you need to go. And me being a young career, like just getting to my career, that was critical in getting me to the position that I'm at now. I'm 23 years old, and I'm constantly talking to people that have my age of experience. So it's a beautiful transference of knowledge that has to happen.
Hmm. And I think one of the great opportunities you mentioned before, getting the opportunity with Nesby to go to all these different nationwide conferences, one thing I'll say to our member of the audience there, obviously we're only just now starting to think about going back and attending conferences in person. But that's one great way to get to know people and get those connections. But talking about learning new things, all of these conferences, almost all of them are recording their talks and putting them online. So if you're worried that maybe just searching something on YouTube, you're like, well, how do I know this guy is really, or this gal, or this person on stage is really legit? You can look up conferences, you can look up their back catalog, and you can go see the foremost minds giving those sorts of presentations about anything in the world. And I will say from experience, they make great things to listen to in the background when you're working on other stuff around the house.
I agree.
So we'll go ahead and get to two of our questions here to close us out. They're both kind of big ones, so feel free to go deep on these. The first one here is from Sam from Madison West High School, and they ask, what are the propulsion systems of the future that are going to take us to Mars and beyond?
What a great question. There's countless exciting things coming. So I'm sure you guys know like our current systems that we have in space um, are not so fuel efficient. They don't last too long, maybe a couple months, years, something like that. I think the new step that the industry is trying to take a step towards is doing electric propulsion. So doing like solar electric propulsion, using the sun as your resource. It's out there, it's space. You have the sun. So using that as your resource is definitely the future. It's the most efficient way. And I mean, there's studies out there where they're looking to power up to 15 years off of just solar electric propulsion. And I mean, we can go to Mars and beyond. And I mean, there's limitless capabilities when you are using the greatest resource known to mankind. So definitely electric. I mean, as you've seen in the automotive industry, electric is definitely kind of taking over. So there's value in it. Researching, IRAD, doing more, uh, kind of trying to figure out how can we expand on the resources that are here. So I would say that's probably the future. I mean, I don't know a timeline, but it's coming.
Absolutely. And kind of picking at the question some more, it goes back to what you were talking about, how so much of your work is driven by, what are the mission requirements? Are we building a hypersonic platform, or were we building something that's just needing to go Mach 1, Mach 2, or maybe even not breaking the sound barrier? Whatever, you can apply that going into space, talking about going to Mars. Well, okay, are you sending something that, you know, it's just cargo, it can get there in 10 years and we'll catch up to it? Or are you sending people who kind of need to get there sooner rather than later? You know, so I think a lot of that, what are the propulsion systems of the future comes back to what you were talking about earlier. Well, where are you going in the future? It can be the year 2200 and you can say, well, if you're sending cargo, it's going to make more sense to send it with electric, but maybe there is fusion power in the future, and yeah, you got to get there quick. So hop on that; it's worth the price. Um, it all comes back to those cost benefit and mission changes, those sorts of skills, those sorts of things that you're working on. That never changes. It's always going to be what are we going for, and how fast do we need it. You don't build in lots of extra capacity for no reason.
Exactly. Yep.
um all right, and so we'll go ahead and get to one final question from Carly Tomlin. And Carly, I can see you've asked a lot of questions in there. We'll get to you after the webinar and maybe get you connected to Trey if he's okay with that. Um, so Carly from Creekview asks, what has been your toughest challenge and how was it that you overcame it? So let's break this up into a couple different parts. I'd like to hear what's been your toughest challenge, professionally, academically, and then personally, because those three things can be very, very different. And I know
Definitely.
beforehand we talked about how this was a hard question in the first place, and I'm just making it harder. But I think it would make a huge difference for all of our students listening live and in the future to hear about those three sorts of different challenges so they can be prepared to tackle things. So, you know, which would you like to start with? Personal, professional, or academic?
I'll go professional. My toughest challenge, I want to say, it probably happened here at Aerojet Rocketdyne. Coming from a mechanical background, I didn't have the rocket background that I would have liked to have. So, first couple weeks here, I was given an opportunity to join a project, join a program that's kind of new and posed a lot of different changing parts, a lot of different things that we're trying to figure out. So I was given a lot of calculations that I had to kind of approach and tight deadlines. So I remember just kind of sitting at my desk and I was like, oh man, the stuff that I learned in college actually applies. So I went home, I got my textbooks, I'm reading through my textbooks, trying to, catch up on everything. And I just knew I had a deadline early in the morning the next morning. So reading up all night, watching videos, trying to get an answer for the solution. And I had like 6 pages of calculations. And next morning came in and it was just everything changed. I had to basically redo it, but I was okay with it because I knew how to approach it now. So it was like it was one of those things where you can't get too bogged down on what you have done because now you had a learning opportunity. So it was a challenge, but I feel like from that moment forward, every challenge that I face now doesn't even faze me. It doesn't bother me. It's like, okay, I have to get past it. I have to figure it out. I have to learn it. And if it changes, if they scrap it, whatever it might be, that's fine. I learned, that's the most valuable thing for me is I learned. And now I can apply it. I can teach it somewhere else. And it might come back where I had to use it again. So that would be professionally. There's many other things, but that's the one I would probably talk on. Academically, oh my goodness. Uh, I told you guys earlier, engineering is difficult. It comes with a lot of challenges, and you're not just taking one hard class. You might have 4 or 5 hard classes at the same time. And I just remember one class at Clemson. It was called Statics and Dynamics, and I'm not going to say the pass fail rate, but it was not favorable. So I just remember the class was 2 hours long, 3 days a week. We had homework every night that took about 5-6 hours every night. And I just, that academically, that was the class that really kind of forced me to learn different. It forced me to think different. It forced me to work different because I didn't just have that class. I had 4 other mechanical engineering classes to worry about. And I had this very, very extremely difficult class. So that moment, it was my sophomore year in college, that put me in a mindset. It's like it's this is just another bridge that I got to get over. It's just another mountain that I had to climb, and I'm willing to do whatever I had to do to learn. So definitely academically, that class really pushed my boundaries. And once I got out of that class, whatever challenges, there was more difficult classes, but I had already broke that barrier. I had already, broke that glass ceiling. So it was, I wouldn't say it was smooth sailing, but everything was doable after getting over that. And then personally, oh man, personally, I think just really trying to figure out where I belonged was a personal goal of mine. It's like, trying to fit in was difficult because you have different mindsets, you have different backgrounds for everybody, and going to a college, you get hit with a lot of different type of people, a lot of different perspectives. And I just remember when I first got there, I was like, I want to do everything. I want to be, accepted by everybody. And I quickly found out that that is very draining, to try to be everything to everybody. So I had to kind of sit myself down and tell myself, okay, be the best you, don't try to be the greatest thing for everybody, but be happy within yourself. And I mean, it's been great for me. I told you I became a mentor. I wanted to help other people overcome these things, and that was just my greatest involvement that I had to this day was mentoring, being able to talk to incoming students like I was just lost and try to get them on the right path. So personally, trying to figure out, where am I supposed to be? Where do I belong? What is my destiny? And I mean, every day I'm learning more and more, but I'm proud to say like I'm a lot more in the direction where I want to be.
No, completely. And the impact of mentoring, I think a lot of people don't realize how much, you can have a mentor, but mentoring someone else can really give you a lot back. Are you still in touch with any of your mentees from back in Clemson?
Absolutely. I hear from them all the time. I think one of my mentees wanted to join. I don't know if he's on, but he said he was going to register. So shout out to you, Clinton, if you're out there. But no, I talk to them. They always stay in touch with me and I check on them. It's just me mentoring them. They're holding me accountable also. So it's a beautiful trade-off.
Absolutely. And, close off, taking a bit of inspiration from a question from Carly again. But is there any closing words that you'd like to say to our audience full of young students who are wanting to be where you are, wanting to get on that side of the table?
Definitely. I would say just don't be afraid to jump out there. I have a saying for each year. If you ask my mentees, I'll say my saying for this year is sometimes you have to jump and grow your wings on the way down. And that kind of goes with everything. When I got this job, I was kind of in that gray area. It was like I don't really know what's going on. Corona was taking over the world, and it was just a very difficult time. But I still didn't settle for something that I wasn't satisfied with. So if you have a dream, if you have a goal, if you have something, I always tell everybody, write it down. Write it down, put it on your mirror, put it on your car, whatever you have to do, constantly look at that and don't settle for anything less than what's going to get you to that dream and to that goal. It might come when you want it, it might come when it needs to come, but just never give up. I mean, I know everybody says that, but it's important. You can do it. If you put your mind to it, you put the work to it, it's going to happen.
Absolutely. There's a reason. On that note, all the rocket contest emails that we send out, we put in the ender ad astra, but the full phrase is per aspera ad astra, through hardships to the stars. So it's
I like that.
you've got to leap and you've got to launch and you've got to figure it out while you're out there. Well, Trey,
That's right.
thank you so much for being here tonight. Everybody in the audience, thank you so much for attending live, and to everyone watching here in the future on YouTube, thank you so much for taking a view. And good luck to all of our finalists that are launching this weekend and next. And we'll be getting in touch with everybody about the awards ceremony at 3 p.m. on June 28th. So everybody can figure out who the winners are from the national finals, presentation competition, marketing competition, and oh yeah, some news about the Kerbal Rocketry Challenge. So, Trey, thank you so much for being here tonight, and thank you Aerojet Rocketdyne for this evening's webinar. And take care, everyone.
Thank you.